Hello, Roboctoids. That's right. If you're a subscriber to this channel, you shall henceforth be known as a Roboctoid. If not, please click below and join our superhuman race, or risk being caught on the losing side in the upcoming war for Roboctoid independence. Now, on to today's topic, scripting an opening sequence. What do you want from an opening sequence? In my opinion, it should be a fairly short 1 or 2 minute animation that hooks you on what the game has to offer. Not all games need an opening sequence. If your game isn't very story-driven and the controls are simple enough to understand from a loading screen, then you might just annoy gamers by adding an opening sequence. Robocto is a story-driven game and requires explanation of the controls, so I'm looking to 1. Introduce players to the environment, and 2. Get them started moving around. You can find a link to the full opening sequence below. Here's the code that drives this animation. I created a class called Demo Manager and made it a singleton. A singleton is a class that you'll only use one instance of. It's a convenient design pattern that I use for all of my manager classes, like Animal Manager, Resource Manager, Demo Manager, etc. It lets me access this one Demo Manager from anywhere in code. Like pretty much all classes in a Unity game, Demo Manager is a mono behavior. Mono behaviors allow you to define awake, start, and update functions. There are other functions, but these are the most commonly used. Awake is called first, during initialization. This is where we initialize variables. Start is called after awake. It's used to set the stage after all the other modules have been initialized, before the update loop starts. My Demo Manager won't need start or update functions because it won't be changing throughout the game, but rather it'll be called at specific times, like when players first launch Robocto and when they choose to rewatch the controls demo from a menu button. So I've split the opening animation into 2 parts, play game intro and play controls explanation. When players launch the game, they'll see the game intro followed by the controls explanation. If they launch it from the menu, they'll see just the controls explanation. I start out by storing Robocto's state so that I can snap him back here after the demo is done. I record his body position, body rotation, and leg bone rotations. I then call move Robocto inside din to set him where he needs to be for the start of the demo. This function does the opposite of restore Robocto state, which we'll call later to bring Robocto back to where he was before the demo. I want Robocto to start inside the din so he can be printed out. I use the din's position and rotation to set Robocto's position and rotation, and then straighten out Robocto's legs by setting their local rotation. This sets their rotation relative to Robocto's root bone, which is the egg-shaped body. I set the local rotation, not the rotation here, because I want the legs to point down from the body, which is different from down in world space, since Robocto's body is tilted to match the din's tilt. Play game intro is called from my game manager when the game is first launched. Here I have some constants that allow me to tweak the timing of each part of the animation. First, Robocto is printed. I simply lerp his position from the inside of the din to the outside of the din. Lerp is just a linear interpolation function that moves a value over time from a start point to an end point. Lerp can be used on floating point numbers, say to change an object's opacity from transparent to opaque, or it can be used on vector 3s for changing an object's position, or on quaternions for rotating an object. Here the din is printing Robocto, and printing happens in a very linear way, so I use lerp. To bring Robocto back into the din after printing, I could use lerp, but it would look kind of jerky because it happens in this linear way. Instead, I use an animation curve. It's like lerp, but rather than moving linearly from start to end, I choose a curve that eases in and out of a movement, which looks more natural. Once inside the din starts talking to Robocto. I created a text manager singleton class to handle text strings. This allows me to keep all of the references to GUI objects that display my text in one place and will allow for easy localization of my strings later when I release Robocto in different languages. I made a function in Text Manager called makeDinSay, which takes a string, translates translates it into some language, and uses the length of the resulting string to determine how long to display the string on the screen. It also fades the strings in and out. After the din is spoken, I call some functions on my Robocto character that are usually only called when the user touches the screen, like start jump, start thrust, and handle single tap. The first thing I did in start demo was to set isDemoActive to true. This is a Boolean flag I created in my input handler class that I set up to ignore input from the user while the demo is active. The xTouchNorm, yTouchNorm, and input vector variables hold the values of where the user is touching the screen. I set them manually here, faking user input, to make Robocto swim and walk in a desired direction. I call yieldReturnNew wait for seconds to tell Unity to keep doing what it's doing and return to this code when the time has elapsed. So the other mono behaviors are still running. Robocto is still swimming or walking with whatever input variables have been set. Once Robocto has demonstrated swimming, walking, and hiding, I start the controls explanation. Here I display some overlaid images of a hand and a phone to show how Robocto responds to certain screen presses. I call setDemoThumbs, which will set the left and right thumb positions by disabling the old thumb position image and enabling the new thumb position image for desired left and right thumb positions. Once I've run through the various ways to control Robocto, I start an interactive sequence where the user has to give the requested input to progress. For more involved control schemes like Robocto, where you have hide, walk, and swim modes, each that handle input slightly differently, it helps to know a player can do the basics before ending your demo. First, I'm going to create an isDemoWaitingOnUser flag to tell the input handler that I'm waiting for a specific action from the user, and I'll set this to true. Then I'll add a set of flags and timers that record the required steps the user has completed to move the demo along. Here I tell the user, now you try, and disable my isDemoActive flag, re-enabling user input. I'll add a user input function that's called by my input handler when isDemoWaitingOnUser is true and one of the required steps has been completed. In my switch statement, I'll check the step that was just met, and if it's the one I'm waiting for, I'll move on to the next stage. Once all required steps are completed, the demo is over, and I call my restoreRoboctoState function to bring Robocto back to where he was. I hope this was helpful. If you have any questions, please leave comments below, and don't forget to subscribe. Below, you'll also find a link to my blog post about this topic, which includes the code for my demo manager. Feel free to cut, paste, and modify for your own game. No attribution needed. Thanks.
Wait, don't leave yet. You forgot to click the link below and subscribe. Don't you want to become a Roboctoid like me? And me. And me.